All right. Hi, everyone. We're here with Aram Harrow. So we're going to ask you just a few questions about your time in your early days in the field and the early days of QIP. So
Great.
first off, what was the first QIP conference you attended?
It was, I think, January 2002, or maybe December 2001, but that year.
And where was it?
Santa Barbara.
Santa Barbara.
Yeah.
So at that time, for the conference presentations, did you use slides or transparencies or chalkboards?
I think there was probably a mixture of like PowerPoint and the plastic overhead transparencies. Yeah,
Okay.
the transparencies were still happening then. Yeah.
Okay. At that time, how many attendees, if you remember, or what fraction of attendees roughly believed that we would have working quantum computers by now, by 2025?
You know, I don't think we talked about that so much. I don't remember. I think there were a lot of forecasts, not from QIP, but there were these forecasts of quantum computing being 10 years away, 10 to 15 years away, and people would get upset because, every few years there'd be a new forecast that would always say 10 to 15 years away.
That sounds familiar.
Yeah. It's certainly true though that we were not looking at sort of near-term quantum computing.
Yeah.
It was there were the asymptotic algorithms, and then there was the single and 2-qubit hardware, and those were pretty far apart.
Okay, I see.
Yeah.
What was a personal prediction of yours from that time that has flopped?
Yeah, good question. I guess there are a few things. I didn't really expect superconducting qubits to do so well.
Okay.
They were just so noisy back then. I did not predict them going as well as they have. And yeah, I guess for the shape of the field, well, I guess a lot of us thought the additivity conjecture for quantum channels would be true. And I guess we also thought that information theory would play a bigger role. And it's been interesting to see that other areas of quantum computing and quantum information have eclipsed it.
Okay, amazing. In retrospect, which talk from your first QIP has been most impactful?
So, okay, this is bad, but I don't remember a single talk from that QIP. But I can tell you a related story. I mean, I think meeting people there was really important for me. I met, Ken Brown, Patrick Hayden, David Bacon, a bunch of people like that. I met for the Vin Van Dam. I met for the first time there, and one story that was very, very important for me was, I think my second ever paper was about a pretty minor result about communication lower bound for entanglement dilution, information theory thing. And I learned at QIP that Patrick Hayden and Andreas Winter had more or less the same result. And we learned about each other's results, and their paper was ready before ours, but they delayed releasing it on the archive until we could simultaneously post. And that was very moving for me, like the early, very early in my career. It really kind of set the tone, in a way that made the field feel very nice to be part of. So that was not exactly a QIP talk, but it was a QIP related experience.
Okay, amazing, thank you. What's the biggest thing that has changed since your first QIP?
Oh, sure, a lot of things. I mean, just so much bigger. The quantum computers are nearer term. Error correction is something that's actually happening. I guess it's also become more computer science-y. Maybe another really big change is initially the talks were all invited. So I actually spoke at a rump session, but the rump session actually meant just the contributed talks. And the majority of talks were invited, and they had a handful of 15-minute contributed talks. And then a few years in, MIT hosted it, and I was a grad student then, and I remember sitting in Eddie Farkey's office. I think there was Ike Chuang, maybe Seth Lloyd, Peter Shore. They were the local organizing committee, and they were also the program committee. And they just went through the list of submissions. I was there because I was helping with the computer stuff. I had made the web form. So they were going through this Excel file, and they were like, take that one, don't take that one, just that's how the decisions were made. So it was a more, smaller and more informal then.
I see.
Maybe also because so many people started off already senior researchers that switched in from another field, it was more top heavy in terms of seniority.
Okay.
So there are very few students like me who started off in quantum computing. So back then it was actually an older conference. So Now
I
there's
see.
a lot more younger energy.
Oh, amazing. This is now a future-facing question. What do you think would be a plausible plenary title in the 50th QIP that would happen in 2047?
Yeah. Yeah, so many possibilities. Yeah, I don't know. NP is not equal to QMA. That would be a good one. Yeah, I feel like it wouldn't be some implementation of a big circuit because someone else would do that.
I see.
But yeah, a good complexity separation, I would hope.
Okay.
Hopefully, we'll have them by then.
Okay. In now a more technical question. In your view, what is the most underappreciated idea in the broader field of quantum information, or within the specific area you focus on?
I think that classical quantum hybrid algorithms have a lot of room to go.
Okay.
You know, I think we're doing quantum algorithms that try to compete with classical without making use of the fact that classical algorithms have already achieved a lot. So I think in the coming years we'll figure out more about how to do that, and that's going to be very important.
Okay. And since you, of course, we must ask this, since you are the first H in the HHL algorithm, one of the most famous quantum computing algorithms, do you have any fun story about how you, Hassadim and Lloyd, came up with this algorithm, or any other associated experience?
Yeah. So, well, Seth had the idea, and then he asked me and Avinatan, and the thing that was very helpful was I was kind of surprised in college how much I liked complexity theory. I was a physics math major, but I didn't realize how much complexity theory is great, and it was taught by this guy, Dan Spielman, who has since moved to Yale. And I just loved Spielman's teaching so much. I was like, I'm going to sign up for whatever he's teaching. And he was teaching a class on numerical linear algebra. And I actually dropped it because I was like, well, I like Spielman, but I really don't care about this topic. But before I dropped it, I learned what a condition number was and why it was important for matrix inversion. And at the time, I'm like, this stuff is very interesting, but I'm never in my whole life going to use it. And you know, it's a good lesson that you really should just follow if there's a good instructor, just go with what they're teaching, and one day it'll be useful, even if you don't know how at the time. So that had been like 7 years earlier, but turned out to be useful.
Amazing. And last question, do you have any other fun story or message that you want to share with the broader QIP or quantum information community?
Yeah, I guess the story I was going to tell was this thing about the Hayden-Vinter simultaneous publication. I think if I have another one. That's probably it for now.
Okay.
Yeah.
Okay.
Yeah.
Amazing.
Good time to talk. Yeah.
Yeah. Amazing. Aram Harrow, thank you so much for your time, and we look forward to seeing you in many more QIPs in the future.
Thank you. Look forward to it.